Earth Science Time. This is the first video period of the 2025-2026 school year. Today we are talking about, if you could write this down, please, Earth's systems. I'm going to put the little S in parentheses like that. I have what I think is a very creative, or I guess slightly creative way to talk about it. So we're talking about Earth's many systems. The class is called Earth Science, so this is the science of Earth. You've heard of Earth both as a planet. The word Earth is used kind of in two different ways in English. Capital E Earth is the name of our planet, and lowercase e Earth is kind of like what we call the solid material that makes up Earth. And so capital E Earth, the name of the planet, like a name, like capital W Will, capital T Tegan. And then lowercase Earth is like dirt and rock and stuff. We'll go into more detail about the materials that Earth is made out of in this lesson broadly, and then also, obviously, that's kind of the point of the class. We'll go into it in more detail. But the objective for today is discover Earth's systems and spheres. So let's write that down, if you would, please. So if you could write after your title, which you've written, discover Earth's systems and spheres. And I'm of two minds about using the verb discover in an objective. I think it's good because what I'm trying to get at is that we're not really getting in depth into Earth's systems and spheres. We will throughout the year, but that's the point of the class. We're going to be talking about this all year long, or all school year long. And so I like the word discover for that because we're talking about kind of a survey level, a surface level analysis of what these things are in general. And because it implies that there's some kind of like wonder, I don't know, like you don't know everything about it, and so we're discovering it. So the objective is discover Earth's systems and spheres. Earth science as a discipline, it says, we break into several different categories. What are the different categories of Earth science, if you could think of them? Let's start with three, and we'll see.
You may change it.
What are some sub-disciplines? What are some areas of, some topics of concern within Earth science, would you say? And these are all, whatever you say, we're going to make them into ologies. You know what I mean by ologies, like studies of. So what are some ologies in Earth? Okay, no. Astronomy, because astrology as a discipline was already taken. Like, since the dawn of time, people have been, since the dawn of humanity, whenever that was, people have been concerned with the stars. And a lot of the ideas that people had about the stars was the way that they seemed to affect people's lives. And so that study of the stars was called astrology. And nowadays, astrology is usually listed as a pseudoscience. That is, that it uses kind of the methods of science, but doesn't really have outcomes in physical reality. And there are issues within issues of that. It's kind of a fraught topic. But astrology in general nowadays is like horoscope, like if you're a Gemini or a Leo or whatever. Astronomy is what we call I'm really trying not to throw shade on astrology, because it's not like, you don't have to put people down to make it seem like astronomy is great. So astronomy is it comes from naming the stars, but it is the observation of physical phenomenon to do with stars and planets and galaxies and stuff. Whereas astrology, again, I'm not trying to throw shade. So it's instead of observational phenomenon, it might be what we could call felt or interpretive phenomena. So astronomy. Other than that one, the rest are going to be ologies. Let's think of another one. What's another topic that the study of what? What other things might we study in Earth science, we might ask? What do you think, Eli? What are some things we might study in Earth science?
What was that?
Oh, yeah. Good. Hydrology is what you're getting at. Eli and I talked about this yesterday. When the ice cream, which is mostly water, rolled downhill, that was hydrology, the study of water and its interactions on Earth science. Good. Thank you, Eli. What's another one? What's something else we might study in Earth science?
Oh, the last thing stars water is the earth and the ground.
Yeah, the earth and the ground. So that's called geology. In fact, the text that I have chosen for this year is titled Earth Science, Geology, the Environment and the Universe. One that probably of these, we spend 1 or 2 units or chapters on this, 1 unit or chapter on this, and then 5 or 6 units or chapters on this. This one tends to be more of the focus of Earth Science. We could come up with more. Do you have any other ones that we might talk about? There are obviously others, and we're going to talk about the relationships between these things in a second. But what are some other? I think many of these were even vocab words, weren't they? Yeah, astronomy, geology. You have hydrosphere, which of course we'll get into spheres in a second, but hydro meaning water. The other 2 that your book mentions are meteorology. Meteorology is the study not of meteors, but of the weather. Meteors are studied in astronomy. Meteorology is the study of the weather. And then it also has oceanography. So couldn't oceanography be part of hydrology? Yeah, in a sense. Hydrology is really concerned more with the dynamics of the movement of water, whereas oceanography is concerned with, actually oceanography comes from the Greek, the writing of the ocean, but it indicates mapping of the ocean. Like the oceanography is the study of not so much the composition of the ocean itself, but the things that go along with that, maybe the features of the sea floor, things like that. So these are some of Earth's the studies of Earth systems are these things. These, I said ologies. Many of these are one's graphy and one's nomi, but they're all studies of. And Earth's systems, I'm going to change colors here. Earth's systems, well, first of all, what is a system? This will get us into something. We're going to have a little side note. Well, what's a system in general?
Like a program.
Okay, yeah, a program could be a kind of system. What else? What's another thing we could say about systems?
They have different functions, like erosion is to get rid of dirt and minerals.
Okay, different functions. I like those. In fact, I'm going to write both of these things down. Program, function. What else? And you both kind of alluded to, in general, when we're talking about system, do we normally consider it one thing or is it many things? Yeah. Many, I'm going to put things in quotes because that doesn't seem like a very scientific word. But one of the points of systems is that we are talking about what we would categorize in science, in our human lives, what we would categorize as many individual things acting as one thing. And I put this S in parentheses there as what I thought was a cute and creative way to indicate that Earth itself is a system. We can think of Earth as a single, interconnected, multifunctional, multifaceted system, one single thing. But we could also, of course, get more detailed or granular with it and think of like, well, of course, within Earth, there's a system of the atmosphere. The way things, let's have another list over here. Atmosphere. That's one of the spheres. The atmosphere is the way that the gases interact. And within the atmosphere, there are many things. Would you consider birds part of the atmosphere? Well, yeah, they definitely exist within the atmosphere. In fact, you and I exist within the atmosphere. Maybe, yeah. The only problem I would have with what you said is not necessarily even more. It's also the biosphere. More biosphere? I don't know. Who is to say which one is more? But it's also the biosphere. And there's another, let's put that on our list of spheres. Biosphere. So here we have another sphere. The atmosphere, the gases and their interactions. The biosphere, life and its interactions. And these are many things. So one of the roles of science in society is to categorize. Basically to chunk up the universe into understandable parts. And so while the master scientist, just like the master philosopher or even the master, I don't know, monk or something religious like that, all realize that this is one thing that everything kind of works together, we also, in our brains and in our discussion, group it, we break it up into many things. Instead of categories, we might call this, instead of things, we might call this categories. We categorizing. That's one of the things human beings do. That's one of the things human beings have always done. Let me give you an example. What's this? Oh, sorry. I have two things. What's this? You've probably seen one of these before. Yeah, a pin. Have you ever seen this pin before in your life?
Maybe once or twice.
Yeah, something like this. But even if you haven't, Eli says no, and he's probably right about that. Even if you've never seen this pin before, you categorize it as pin. You observe it and you notice its function in its form, and in your brain says pen. I've seen pins before. I've never seen this pin, but I categorize that as pin. That's one of the functions of science in society, and that's one of the things that when you do science, first of all, you do science. Science is not just a thing that you learn. Eli's notebook correctly says you have to learn it, and that's true. But science is a thing you do. Anytime you're looking at the world and observing it and asking questions, observe, question, conclude. Anytime you're looking at the world, asking questions about it and making conclusions about it, that's science. So one of the things science does is it categorizes, it breaks down what we understand to be unified system into more manageable parts. Manageable. So, as I said, the master scientist, like the master philosopher, understands that it's all one thing. The universe, right? Uni meaning one, that all of this is one thing. But for our sake, we break it up into individual things. That's what science does. Let's think of an example of that. Sometimes people have a really hard time with this. You feel like you're one person, right? Do you also feel like you are a stomach and a backbone and a pinky fingernail and a kneecap? You don't feel like those things individually, right? Like you feel like all of this is kind of moving around as one thing. But of course, if you think about it, and when you learn about it in third grade, you realize that, oh, my skeletal system, like my shin bone, is in a way different from my cardiovascular system, like my heart I can feel beating, right? You know that those things, at least we categorize them differently. But also, so when you don't know anything, I love my 18-month-old daughter, but she basically knows nothing. When you don't know anything, you feel like you're all one thing. And then you go to school and you learn, oh, actually, I am a skeletal system and a nervous system and a cardiovascular system. And I'm made up of all these parts. But then when you get a little bit older, you realize, actually, my nervous system wouldn't function without my cardiovascular system, which wouldn't function if it wasn't fed by my digestive system and stuff. So then you realize again, like the master scientist, that it's all one thing. So it seems to be many things these systems do, but it's also all one thing. And so let's list some more of those systems. So Earth itself is a system, a single system. There's a lot of stuff, or what we would categorize as a lot of stuff working together. But what other things do we have? Atmosphere, which is gas. Biosphere, which is life. What else? What other spheres are there?
Geos.
The geosphere, and like we had for geology, what's the geosphere probably mean?
Earth.
Earth, yeah. And I'm going to put lowercase e Earth, although in my very unique and not always very beautiful handwriting, the lowercase e I also use for capital E, so you're just going to, this is meant to be lowercase though, the Earth material. What other spheres are there? Let's think of at least two more. What do we study, Eli, in our, remember we talked about hydrology. What would we call a sphere related to hydrology, do you think? Hydrosphere.
Oh, yeah,
Because it's hydro, yeah, water, exactly right. All the water.
Does the last one have to do with space?
No. Usually we restrict, when we're doing earth science, we restrict our studies to within Earth's system. But the last one, and we don't, everything's kind of inherently political. We can have arguments if you want. This book doesn't mention it, but I do want you to realize that some people consider the anthroposphere to be a separate thing. And this I'm going to put man. And I don't mean man as distinct from woman. I mean man as distinct from the other organisms. Well, we could put humanity. It's male and female, but anthropos is from the Greek for man, and so I put man. So that is the sphere of things that humans have changed about their environment. Now, back to my point about Earth being a single system. Is it that we have an atmosphere, and then a biosphere, and then a geosphere, and then a hydrosphere, and then, I don't know, what color is man? Orange, I don't know. We're going to put red. Anthroposphere. Are these individual spheres just floating in space? Of course not. In the same way that you don't exist as a skeleton and a brain and spinal cord and all your nerves and stuff, and a heart with blood coming out of it, and a stomach full of, what do you guys have for a snack? Popcorn. Like, you don't exist like this, like 4 different spooky monsters walking around, right? All that stuff smooshed into one beautiful person. All this stuff smooshed into one beautiful blue marble, right? Our home. So it's all one thing, but we in our brains, for our benefit, categorize it into multiple different things. I do want to keep all of this up here, but we talked a little bit about the science. One of the roles of science is to categorize. One of the ways that we do that, and I would pan the camera if it wasn't going to be so inconvenient, but I have these posters over here. Just say them out loud for the benefit of those of you watching the video afterward, probably Cody. Over here we have, and I want you to list these. I'm going to go back to the board in a second, but we have, do you see these 2 posters? These are really important posters. I love the painting Tegan made me of Don't Throw Things in Class, but probably this is the most used by the most people, 2 objects on the wall in here. In a couple of classes, this periodic table is used in those classes the most, but by the most people who come in this room, we use these. These are the most important posters probably for this class. We have science and engineering practices. These are things that scientists, people who observe and categorize and conclude about the world, and engineers, people who design solutions to problems, use all the time. These things are used all the time, whether people think of it or not. I mean, it's not like a person who is in a white lab coat being a professional scientist doesn't think, today I'm going to construct explanation and design solutions, right? They don't actively think these things, but they do them all the time. And in fact, you do them all the time, whether you realize it or not. And then we also have these cross-cutting concepts that are ideas, concepts, that cut across all the different kinds of science. These apply to all different kinds of science. And so I probably won't even write them on the board because they're back there. But we have, of the science and engineering practices, follow along with me. I'm going to read off of there as I'm just coming back so the camera can see me, I guess. Number 1, asking questions and defining problems. Do you guys ever ask questions or define problems? Of course you do. Like what's that thing on Tegan's bag? What is that? That's a question, right? Do not answer that. I don't want to have that be part of this video. But if you didn't know what that was, you might Google it. I mean, or I don't know, maybe you kids are beyond that. You chat GPT it. I do not agree with that. But if you would have a question about that, you might ask your mom, I don't know. But you ask questions all the time about your world. Developing and using models. Well, a model, if you remember, is a simplified representation of a natural phenomenon.
So like our notes.
You like your notes. Like this. Really, even though this might be very artistically valuable, obviously this is a beautiful drawing. I did a great job. You might be able to recognize that this is not a real skeleton of a real human being, right? That's a model. This is a simplified version. What about the skeleton in Mr. O's room? Have you guys ever seen that?
Yeah.
Is that a real human being skeleton?
No.
Nope, it's a model. Do you ever use models? Do you ever use simplified versions of things to get things done?
Yes.
Have you ever built Legos?
Yeah, those are fun.
Yeah, that's a kind of model. Planning and carrying out investigations. Maybe to you it doesn't feel like you do this all the time, but you actually do. An investigation is when you are looking for information. while you are researching whatever that horrible creature is that's stuck to Tegan's backpack, you are planning and carrying out an investigation. The planning part is, I need to figure this out because that thing gives me the creeps. So you plan it out, and then as you investigate it, that's an investigation. Analyzing, interpreting data is when you are looking at the way something has turned out. So you ask ChatGPT, what is that thing? What is that thing? Does ChatGPT do the picture thing? Can you do that? You take a picture of that. I wouldn't. ChatGPT will spit out something and you will analyze and interpret that data. ChatGPT will say something that you need to analyze and interpret. It will need to be digested by your own mind. Next, look at number 5. Using mathematics and computational thinking. Do you ever do math? Sure, of course you do. You've been learning that since you were in kindergarten. Maybe you don't like it, but you should love it. Constructing explanations and designing solutions. If you construct an explanation, that is explaining whatever phenomenon you were analyzing in the first place. Designing solutions. Have you ever solved a problem? When I had to install my dishwasher, I'm trying to specifically use non-science examples. Like we do this all the time in science, but when I was installing my dishwasher in my house, the brackets didn't fit exactly where they were supposed to, and so I had to come up with a solution. I still had to have the dishwasher. I paid $700 for it, and so I had to figure out a way to get the dishwasher installed without using those exact brackets. Engaging in an argument from evidence. Now this one trips people up because this is not like when you say, Mom, I'm going to the movies, and she says no, and then you guys yell at each other for 25 minutes. That's not the kind of argument this is talking about. An argument from evidence is more like a persuasive speech if you've ever done speech. It's like, oh, what we were saying about the anthroposphere. Evidence suggests that human beings change their environment. Some people refuse to believe that. Other people want to change everyone's life based on that. And that causes an argument. Sometimes it is an argument in the way that your mom and you argue about who's going to go to the movies or not. But other times it's just, here is the evidence. Here's my interpretation of the evidence. This is what we should do based on that. That's an argument. And then if it's from evidence, that means that you're using observations from the physical reality for that. And then finally, the SEP, obtaining, evaluating, communicating information. That's when you take what you learned and you tell someone else about it. You say, have you seen the thing on Tegan's backpack? It's an abomination. We shouldn't have those anymore. And then you tell people about that, and that's a... Look at his gross little hands. I do not care for that thing. So those are the SEPs. Those are the things, and I use those examples that I did because I want you to realize that this is not very far removed from what you do all the time. The main difference between what we do in this room and in science in general, and even what a professional scientist does, and what you do in your daily life, is that you write it down in here, that you record those observations. That's what makes it science instead of just, I don't know, messing around. And then real quick, we're going to go through those CCCs, the cross-cutting concepts, the ideas that go across all the types of science. Patterns, cause and effect, scale, proportion, and quantity, which is basically size. Systems and system models, again, many things working together to make one thing. Again, it's not like they're not working in the way that Will works at C's, but they act together, they interact. Energy and matter, structure and function, that is what a thing looks like and what it does. Stability and change. You've heard of change, I'm sure you have. Do you have questions about any of the CCCs or SEPs?
No.
Do you know where to find those?
Yes.
On every single lab, it will have a question that is, which CCC, which cross-cutting concept, best applies to your lab? And explain. And the most important part is explanation, because those cut across all the kinds of science. You could always say any of them, but I want you to explain how that relates. Do you have questions about Earth as a system, as what we break up in our minds into individual spheres, but they actually are one unified entity? Do you have questions about that?
No.
Do you have questions about these different studies that we do within our science? Okay, your book has quite a lot about the way we take measurements in science, which we'll do throughout the year in the lab. Your book has quite a lot about scientific theories and laws, which are in your vocab. And I think you should be able, between what you have already done in your vocabulary, using your book and what we've discussed here, you should be able to complete your chapter review. You have any questions at all?
Have we discussed?
Oh.
Have we discussed the due date on the chapter review?
Yeah, we'll do that after the video. My plan is for it to still be due Monday. The day's Thursday. You'll have tomorrow to work on both your lab and your chapter review, and then Monday they'll be due. We are going to, this might be the only objective throughout the year that we don't actually meet on that day. We are throughout the year going to discover Earth's system and the spheres, but today we have enumerated Earth's systems and spheres.